Hi everyone, I'm Vishal and this is my teammate Rohit, and we're going to talk about our project PyOverflow. So our project is to classify Stack Overflow questions on Python into classes defined by the Python documentation. This can help users using Stack Overflow to navigate to questions that are similar to the initial question that was asked by the user. So a basic example of how our model works, we take a question from Stack Overflow, pre-process it, input it into our model, and it gives us a label that is defined by the documentation. So the training data used are sentences scraped off of the documentation under different categories. These categories are the labels for the sentences. So we scraped a total of 300 sentences across 4 labels, which are built-in types, exceptions, regular expressions, and strings. And over here you can see the final clean data that has the content, the topic, and the associated label. First, for the test data, these are Stack Overflow questions tagged Python, and the subtags are the labels such as the ones mentioned before. So we collected a total of 392 questions across these 4 labels. We removed the code blocks from them and used only the title and the body of the question. And this is an example of a cleaned question that's given over there, as it has the body, the title, the associated tags, and the label. So just to go over the data processing pipeline, for the trained data, we used the beautiful soup library, which scraped the web pages to give us JSON files. These JSON files were then converted to CSV files, which were then cleaned to remove special characters and code blocks from the text. And then the text itself was split into sentences and given unique labels assigned to each documentation category they were scraped from. The test data uses SQL commands to retrieve Python questions from the Stack Overflow data dump. The SQL tables are further filtered using the tags. The files are then subjected to the same data cleaning as the training data, and then given labels based on the tags that were filtered with. The models that we've used, the main model we've considered is GPT-2 medium, which has 355 million parameters. This was fine-tuned with a classification head to give us our 4 labels. The baseline we used was a simple CNN model that was trained from scratch, which also had 4 labels at the output, and that's the architecture that we've used for the CNN model.
Okay, let's look at some examples. This question talks about regular expressions. That is fairly easy and doesn't have any confusing terms and well explained. So, and also GPT-2 labeled it correctly as regular expressions. This is the best case scenario for our model, where the question belongs to one particular class or a label. Let's look at another tricky question where the question is on regular expression but talks about exceptions. Now the question has 2 different labels, regular expressions and exceptions. This is where the model was shown to be struggling. We created 3 different variations of training and test data to see the effect of data on the same model. Let's start with training data. The first version is the most basic one, where each sentence in documentation is 1 row in our training data. Moving on to the next second version, we combined 3 sentences together with overlap. So like sentence 1 becomes sentence 1 plus sentence 2 plus sentence 3. And sentence 2 becomes 2 plus 3 plus 4, and so on. Let's call this version as overlap. Moving on to the third version of training data, it's the same thing but without overlap. Let's call that version as no overlap. As the name suggests, there are no overlapping sentences in the training data. Similarly, for the test data, we created 3 different versions of Stack Overflow questions with just title, just body, and the combined title plus body. This is the graph showing performance of both models on all the combinations of our variations. The baseline performs as expected, where as the input increases, the accuracy slowly declines. Input size increases. However, the GPT-2 model is much more interesting. We could see an exceptional spike in accuracy when the training data is overlapped and test data is combined. One possible reason for this behavior could be that as the sentences were repeating themselves, the model was able to recognize patterns and learn specific programming words and phrases. The GPT-2 model was performing worst when there was no overlap, possibly due to the training data being reduced to 1/3 of its original size. Coming to the learnings, it was interesting to see how the same data in different forms can affect the model performance. And if we were to do the similar project again, we would definitely focus more on data. And we also plan on improving the performance further by adding some cherry-picked Stack Overflow questions from into training data and reduce the difference between training and test data. That concludes our presentation, and thank you for listening.